This is a question from algorithms. Consider the following algorithms and their running time complexities, and we are asked to map it. So first one is BFS. BFS stands for breadth first search, and the time complexity is order of V plus E, where V represents the number of vertices and E represents the number of edges. So in BFS, it is a breadth first traversal of a tree. So A is mapped to 2, and with BFS we can say that the time complexity is increasing linearly with the number of vertices and edges. Now second one is Rabin-Karp. The time complexity of Rabin-Karp algorithm is often defined as order of or theta of n minus m plus 1 times m, where n represents the length of text being searched, that is text length being searched, and m represents the length of pattern being searched for, m pattern length. This is Rabin-Karp algorithm. So B can be mapped to 3. Then we are having depth first search. In depth first search, it is the worst case or time complexity is theta of V plus E. So this is the time complexity where V represents the number of vertices and E represents the number of edges. So C can be mapped to 1. Now in heap sort and quicksort. In heap sort, the worst case time complexity is order of n log n, that is n log n. This is the worst case time complexity for heap sort, where n represents the number of elements to sort, n log n. And whereas quicksort, it is order of n square. For quicksort, it is order of n square. And this n square happens either when the array is already sorted, so that the partition divides the pivot element into two unequal halves. So E is mapped to 4. So let's see which option is correct. Based on the options, we can say option C is the correct answer because A is mapped to 2, B is mapped to 3, C is mapped to 1, D is mapped to 4, and E is mapped to D is mapped to 5, and E is mapped to 4. So based on the options, option C is the correct answer here.